Hello again, all you lucky people. Hello. Harbinger here again. I'd like to introduce you something that I modified. This was a Carl. It was a Carl 1kW once upon a time, but it wasn't. Whoever had it before, when they sold it or resold it, it'd been gone through, I don't know how many numerous times. It had dissimilar finals in it. It was a mess. It was all put together with two-way tape and glue and lots and lots of hot glue. And that's something I'll rarely, if I ever use it. But anyway, I kind of did a different configuration from what everybody else does. Instead of these power supplies here, these are your 1200, but they are not ganged together for load sharing. They're basically just strapped to turn on when the contactor turns on. I've discovered with these particular power supplies that they draw about a good 7 watts a piece on 120, just sitting while they're off. Well, that little jumper, if you disconnected it, it's supposed to turn the thing off, but they still draw current. So I didn't care for that. So I put a contactor in there because I can't see this thing drawing 20 watts or 25 watts of power while it's just sitting there off. So anyway, it's got this big old fat contactor in there now. And and the other thing, if you notice on the output here, you don't see a coil. There is a coil, but it's on the inside. I don't think there's any way I could get in there to show you, but there's a coil way down in there, and it's inside. It's inside some Teflon. Some of that. It's either 3/4 or half. I think it's 3/4 Teflon, and it fits in this tuning capacitor perfectly. Also, I'm using the larger ferrites on the output. Everyone keeps using those little half-inch jobbers, half by halves on the output. I don't know why, but I believe this will be able to dissipate a little more heat a whole lot faster. Of course, I'm using metal oxide 5 watt 100 ohm resistors on there. The coax, the reason why I put these combiners here on top is because it allowed me to only use 1 yard of coax. Well, you know, half a yard for the output and a half a yard for the input. I notice everybody's building these things with almost 5 yards of coax. Or yeah, 170, I think I calc 177, 170 inches or something like that. It's ridiculous. I'm not, I don't consider myself to be an engineer, electronic engineer, even though I built this thing. But I do know 5 yards of coax versus 1 yard of coax, you know, you're gonna have a little bit of loss. Anyway, I stole a little idea from BBI with the output combiners, powering the finals. Of course, I didn't use his transformers, but these work just as well. And But there are some differences I discovered by using less coax. It changed these output caps to from 150, which everyone's been putting in theirs with all that coax. 150, it changed it down to 100 in order to be resonant. Same with the inputs. The inputs also had to be changed. Those, according to standard cookie cutter amplifier building, from what I could see, they're using 180 picofarad, and with these it's 120. That's where she wound up being resonant. Of course, the 330s remain constant. The 120s that are on the collector of all your transistors, and when your 1000 picofarads, of course, across your combiners, those remain constant. This thing, I used the number 12 wire, and just basically soldered it to the pads, made some loops to run the conductor through, number 6, and of course ran it down all here in a bus bar underneath there. The ground, of course, is right on the finals, goes right across, strapped across the finals themselves, so there's no loss. I see people grounding their stuff way out here on the board, and this little thin piece of foil board, you know, it's not really designed to conduct a whole lot of current. But I see them doing it. This thing is rigged up for bias, but I haven't. I've had some pretty bad experiences putting bias on these new HGs, these C model 2879s. So I'm going to have to do a little bit of more research before I start putting bias on these things. Besides that, them increasing the duty cycle with bias, unless you're using it on sideband, it's going to get these transistors really hot, and they get hot really quick. That's one thing I notice about this beast. It gets hot pretty quick. So, I'm going to get all rigged up here to do a test. This is pretty much a proof of concept. Let everybody know that's been, I guess, teasing the hell out of the person that I'm building this for. By the way, I'm not a builder, so don't ask me to build another one of these damn things, because I'm not a builder. It takes a lot of resources that I don't have. I'm just a garage. I'm a hobbyist. Pretty much my bench stock consists of what you see right here. That's about it. I don't have overhead. I don't have insurance. I definitely am not an engineer. I'm not licensed at this. And anyway, once this thing gets paid for, I'm taking it off of YouTube. But I'm just putting it out there just so everybody could see that it really did get built. It really does exist. And sorry my camera's so shaky. Anyway, let's see what it does. Okay, here we got my my old cheapy Connex here, 4400. It's turned way down. I mean, way down. Let's see here. It's on the 3-watt scale. It's always RMS. Like I said, I don't like lying to myself. So here we go. Whoa. That didn't exactly work, huh? Well, I'm doing something wrong. That's probably the modulation. Let's see here. Let's try this again. Whoa, that is really low. Okay, so that's a couple watts. Let's turn this little bitty cheapy amplifier on and see what we have out of that. Okay, that's drifting up to 10. That's the drifter it is. And get a little bit above 30 on there. So that's not too bad. But if I put it on the 100-watt scale, I mean a 300-watt scale, it'll probably be a little more accurate. Let's see here what we get. Yeah, see, look at that, 75 watts. Okay. But for general purposes, I'm going to crank it down to 50 if possible. So she's swinging almost up to 50. Now let's go ahead and go to operate. Dun dun dun. And let's see what the dead key is. So the dead key is about 50 watts. I'm going to turn this switch up to 3K and see what she does when she's modulated. Alright, a little bit above 500. Not bad, especially considering how little we're hitting her with. Now if I turn the modulation up and I turn my operate off and I go back to the 300-watt scale with the with the mini amp on, this is what we have. Okay, 75 watts. Now let's see what she does. That modulation's not turned all the way up. I have it about halfway. And I'm using a little cheapy stock mic. Using an old Superstar mic. It's seen its better days, but she's still operational. Alright, let's see what she does with a swing up to 75. Alright, I gotta flip the, put it to 3kW. Alright, baby. Oh. Yeah, wow, okay, 2000. That was pretty easy. Like I said, I got this power turned way down. But if I crank it to, let's say, a base of 500, let's see where she swings to. 2500. All right. And that's still 75 watts of input with a little more modulation. Anyway, that's about all I'm going to do to this thing. Well, I still got a few other things I want to do to it. These fans, I actually want to give the take them off, do the cover. Give the cover another little thing of paint. But other than that, this thing's ready to go and make somebody angry. Well, those tests, the fan light still hasn't come on, or the thermal fans, the thermal switch. It has two settings. It's got a low. Of course, these are those super quiet, low power Arctic fans. Anyway, this guy wants this thing to run off at 220, so I got to change that contactor. I got one that's identical, it's just 220. And redo a couple solder joints, clean it out really good, make sure there's nothing in there unusual. This slide capacitor, it was pretty easy to adjust. I might stick another leg on it and ground it underneath. I think it would benefit from having the extra ground. And other than that, this thing looks really good on the spectrum analyzer too. And just had a couple little harmonics sitting way out there. They weren't very impressive looking, but it did not look like a field of grass, so I'm pretty happy about that. Oh, look at that, the light just came on. Oh, I turned it on, never mind. This thing never did get hot enough, just those few little tests I did. But, yeah, I got the idea of putting the coil inside this capacitor after proposing it to ChatGPT, and basically indicated the specifications regarding the parameters of which I required, and just basically laid out the design to ChatGPT. It went over it and said it looked good, except for I should use number 8 as far as conductor. And so that's what I did. And of course a high rated contactor. This circuit's not typical. And of course it has a remote keyer. That's what that little plug is right there, that little jobber. But it's actually a 2-stage transistor keying circuit that I generally build for these heavy-duty relays, these heavy-duty contactor type relays. And anyway, that's all I have. That's this is what she does and what she looks like. And it took me about 4 months to build it. I spent more time trying to dial it in and trying to find what components actually needed to allow this thing to be resonant from the input to the output. Lower down the input SWRs, all kinds of really fun stuff that it took to do this. But got her done. Anyway, you all have a good one out there. If you do get mad at somebody and want to use something like this on them, please hurt them with some mercy, will you? Don't hurt them so bad. You have a little bit of mercy if you're going to do it. Anyway, to each their own, as I say. With power comes responsibility. Please treat it as so. Treat it with respect. All right.